Hey Wildcats, welcome back to the STEM Lab. Today I'd like to talk to you about changes to the Earth's surface. Many of the features on the surface of the Earth, like mountains and valleys and plains, are created very slowly over hundreds or thousands or even millions of years by processes called weathering, erosion, and deposition.
This is a simulation of those processes. Weathering and erosion are caused by gravity, wind, water, and ice. Weathering is the breakdown of rocks into very small particles, and erosion is the removal and movement of those particles from one place to another. The rock on the mountain is being broken down, weathering, and then the particles move down the mountain, erosion. Deposition is the buildup of land by the settlement of those particles in a new location. When the particles reach the bottom of the mountain, they start to pile up again because there's nowhere else for them to go. This is deposition. The changes you are seeing in this video would take millions of years to occur to the actual surface of the Earth. You will learn much more about weathering, erosion, and deposition in 5th grade.
Other changes to the surface of the Earth can happen very quickly. Events such as volcanic eruptions, earthquakes, landslides, hurricanes, and floods can occur very rapidly and completely change the surface within days or even hours. In today's lab, we're going to look a little closer at how the surface of the Earth is changed by volcanoes and landslides.
Volcanic eruptions can be pretty violent, explosive events. Deep inside the Earth is so hot that some rocks melt and become a thick, flowing substance called magma. Over time, the magma rises and then eventually pushes or erupts through the Earth's surface, forming lava, which glows red hot to white as it quickly flows from the volcano. As the lava cools, it thickens and eventually hardens to form igneous rock. Over time, as the volcano continues to erupt, it will get bigger and bigger. Let's take a closer look at the formation of volcanoes. For this experiment, I have 4 colors of Play-Doh, baking soda, vinegar, yellow food coloring, a small dropper called a pipette, the cap from a tube of lip balm, a paper plate, paper towels, and a pen. I'm going to put a little bit of the food coloring into the vinegar, just so it's easy to see. I've now taken the cap and packed some baking soda tightly into it to get it nice and full. And now I'm going to fill the pipette with vinegar and quickly squirt it into the baking soda, which will create our eruption and lava flow. And now I'll take my pen and I'm going to trace around the shape the lava flow made. I'm not sure that this pen is going to do the best, so let me take another one, go over it, different type of pen. And then I'll take a paper towel and clean up the cap and all of the vinegar that's on the plate so that we're left with the shape of our flow. Then I'm going to take some Play-Doh. Let's start with blue. And I'm going to take some out and I'm going to mold it onto the plate into the shape of our flow. All right, there is the beginnings of our volcano. And I'm going to repeat the steps a few more times, and I'll use a different color of Play-Doh after each eruption. So I've got the cap once again filled with baking soda. I'm going to put it each time right in the middle. And so now I'll take some more vinegar and make another flow. And again, I'm going to trace the shape of the flow. And I'm going to put some marks right in here too, so that we can see how the flow landed on top of the existing structure. And then we will go ahead and put some more Play-Doh on it. I think I'll use yellow this time. All right, so we have the second layer, and I'm just trying to get it a little bit smoother since I had to use so many different little pieces of Play-Doh. Just trying to smooth it out some. All right, let's do it again. Okay, I think I got this right. It was a little bit hard to see the yellow food colored vinegar with the yellow Play-Doh, but I think I got the shape pretty well. So we're gonna do it again. Now you can see how that eruption came out even farther, and so now it's building some landform over here. And you can see in the middle here it's getting taller, and then it's starting to slope down at the sides. So I'm gonna do a few more layers, and I'll keep the same order of Play-Doh. So I'll start again with blue. So our volcano has now erupted 8 times, and you can see that this is the structure that we ended up with. Now remember, before the first eruption, there was nothing. And so it's built up pretty high, especially in the center, over each eruption. If we continued to do eruptions, placing the cap in the middle each time, it's going to keep getting taller and taller in the middle and then sloping down. Hopefully it gives you a little bit better idea of how volcanoes are formed. Now let's learn a little bit more about landslides and what causes them.
The surface of our planet is constantly reshaping itself, and landslides are a major reason. They strike wherever the soil is loosened by rain or tugged by gravity. It can be a rockfall or a raging river of mud. But wherever the ground fails, it can result in massive destruction. They can crash down without warning and travel for several miles. Landslides usually follow other natural disasters like volcanic eruptions, earthquakes, wildfires, storms, and floods. Steep slopes are obvious places for landslides, as are areas that have been hit by landslides before. But they also frequently occur where people have radically altered the landscape. Hills stripped of vegetation, slopes modified for roads and buildings. As long as the earth continues to move, people will live with the threat of landslides.
Let's take a closer look at landslides. For this experiment, I have 150 milliliters of sand, 50 milliliters of pebbles, a small styrofoam cup, a water bottle with a hole poked in the lid. I have some extra water, a paper plate, a pie pan, pen, and some colored pencils. First, I'll take the styrofoam cup, put it in the center of the plate, and use my pen to trace around it. This is where our mountain will go. All right, I used my colored pencils to draw some structures around where the mountain will go. Some houses, some trees, and a road, just to kind of remind you that, when you do have mountains or big cliffs or things like that, a lot of times there are communities around there. Now I'm going to put the sand and the pebbles into this container, add some water, and mix it up. And this is what we're left with. So now I'm going to take this mixture and pack it tightly into this cup. It needs to be packed as much as possible so that we can make the mountain as solid as we can. I'm going to take the paper plate and I'm going to put it over the cup as close to where I traced as possible. And I'm going to very carefully flip it over. I'm going to set it right here in the pie pan. And I'm going to take the cup off. It's kind of like building a sandcastle. And hopefully it'll come out all right. It didn't want to all come out of the cup properly, so I have done my best to mound it up as best I can, and there we have a mountain. Now we'll see what happens after it rains. I'm going to turn the water bottle over, and I'm going to drizzle water onto the top of the mountain for 3 seconds. You could see that there was a little bit of movement of the side of our mountain, and obviously an actual mountain would be made of very solid rock, so after one rainfall it wouldn't move like this. But this experiment is basically simulating what would happen over thousands of years. Now we're going to see what happens when we have some super heavy rain. So I'm going to take my water bottle again. I've put some more water in it, and I'm going to turn it upside down and I'm going to squeeze it to make a heavy rain, and I'm going to do this for between 3 and 5 seconds. So you can see with the heavy rain, we definitely had a landslide. The mountain moved out considerably, and in the process, it destroyed a tree, a couple of trees, part of a house. On this side, we have some damage to this house, and it's gone right up to the tree. This tree and this house were lucky because the landslide went the opposite direction. And the road, most of the road is okay, but there was definitely some landslide that came down on this part of this road.
I hope you've enjoyed learning more about changes to the surface of the Earth. I'll see you next time. Bye.